So what we learned yesterday was a kind of a basic idea about dividing radicals. So we had something just to have a very simple example to remind you of yesterday. We could have had something like this, which could be rewritten as square root of 8 divided by 2. You know, we just put it under one radical. When you do the 8 divided by 2, you get square root of 4. And this, I made a very simple example. We know the square root of 4 is just 2. And we're done. You will have problems like this. So it's important to know how to do that. And honestly, a lot of times it's going to look pretty basic, something similar like that. So you're going to be seeing some difficult problems today, potentially difficult, but they will get easier next week when we're looking at this in the context of some triangles and what we call special right triangles. Okay, but that'll be next week. Today we need to learn a little bit more about dividing by radicals, because now we have a different situation. And this is not like yesterday's where it's a radical divided by a radical. This is a whole number divided by a radical. And honestly, we don't change this answer very much, but what we do is what we call rationalize the denominator. And we say rationalize because this square root of 8 is what we call an irrational number. You might have heard of that before, rational and irrational numbers. The important thing about it is that we cannot have a radical left in the denominator. So we want to get rid of that. And the way that we rationalize the denominator is we turn this into a rational number, which that makes sense, I guess. So as we're figuring out how to do that, it's basically just a trick to simplify this more because it doesn't change our answer fundamentally. In fact, whenever we go from square root of 96 to 4 square root of 6 as our final answer, this hasn't changed the value in any way. It's just simplified it. And this looks a heck of a lot simpler than this one, at least according to the rules of mathematics. So what we're doing is we're just simplifying this right here by getting that irrational number out of the denominator. All right, so to help this make sense, the first thing I want to remind you of is if I just did this, if I took 3 over the square root of 8 multiplied by 1, you already know we get 3 square root of 8, 3 over square root of 8. So there's nothing fancy going on yet. Another thing we can do, what if I rewrote this 1 like this, as 1 over 1? Okay, well that's 3 over square root of 8. Okay, so I could do some other things here, but now basically keep in mind that when I multiply by 1, I'm keeping this value the same. It never actually changes its value. So now what I'm going to do is I'm going to multiply by 1, but I'm going to do it in a weird way. Instead of 1 over 1, I want to do square root of 8 over square root of 8. And I'll talk about this more, why I picked this, but essentially, notice that the square root of 8 in the denominator, I just took that number and made it that number over itself, and I multiply by that. Now, square root of 8 over square root of 8 is still just 1, right? I think we can all agree to that. But let's see what happens here. So when I multiply across the top, I get 3 times the square root of 8. All right, nothing super fancy going on. Then when I multiply across the bottom, I get square root of 64. And this 3 square root of 8 now can sit on top of, we know the square root of 64, it's just 8. And at this point, this is as simple as we can make it. Now, potentially these two whole numbers could be divided and then we could do some more math. And we'll see some, I'm going to go through a few examples of this. And let me just mark this real quick. Sorry. I'm going to go through a few examples of this, and we're going to see some where there's more to it. Now, this actually isn't as simple as it can be. Hopefully you guys caught me on that. So I lied when I said that, because now what we can do is we can figure out, is there a way of simplifying this radical anymore? And we can. So we can divide this into the square root of 4 times the square root of 2 over 8. And now we know the square root of 4 is just 2 times the square root of 2 over 8. And now we can see what's going on. So I'll just go ahead and multiply this out at the top. So it's going to be 6 square root of 2 over 8. Now this 6 and the 8, this is what I was talking about. This has a common factor. I can divide both of these by 2. So this becomes 3 and that becomes 4. Just like simplifying any fraction, and we just leave that radical as is. So 3 square root of 2 over 4. And there it is. That is as simple as I can make it. I can't simplify this down anymore, and that square root of 2 just stays there. So here's what it looks like in delta math when you plug that in. So we know how to do 3 square root of 2. But now notice that I'm going left and right here. When I go to the right, I'm out of the radical, and I can hit the backspace button, and it creates a fraction for me. So 3 square root of 2 over 4 is my answer, and that is correct. Like always, it shows the steps right here. So we want to multiply by that radical over itself, and we get all these steps. Okay, you can see how they did that, which is how we did it. So all good. So this is called rationalizing the denominator. This value right here is essentially the same as 3 divided by the square root of 8. It's not essentially, I mean, it's exactly the same number. If you plug that into your calculator, you would get the exact same number. But this is the form that we prefer as the simplified version. All right, whether you like it or not, that's the way in math, it is the standard way of doing it. Okay. And that's going to be important to know for next week. So in fact, what I'm going to do now is we're going to pause and we're going to look at some more examples after your webinar. So we looked at rationalizing the denominator, but I just want to do a few more examples because I think once you see maybe 3 or 4 examples of this, it'll make some sense. But keep in mind, if you want to just go through some more examples before class ends, then let me know and we can go over that. So here's a new problem. And sure, let's go with this one. 1 over the square root of 28. And just the key thing is we never leave a radical in the denominator. It can be in the numerator. And what we want to do here is we want to see whatever is in the denominator. And I want to take that and put it into a fraction where it is both the numerator and the denominator. So I want to have the square root of 28 over the square root of 28. And I'll just go ahead and erase this real quick. And then I can just multiply that out. So whatever's in the denominator gets put into a fraction over itself. And that's essentially multiplying by 1. So we're not changing the value by doing this. But when we multiply across, 1 times square root of 28 is just square root of 28. And square root of 28 times square root of 28, now that's going to be some big number, close to 900. I don't know what it is, 800 something. But here's the thing. When I multiply the square root of 28 times the square root of 28, it just becomes that same number without the square root. So let me write that a little clearer. It's just going to be 28. So we can figure out what 28 squared is. But bottom line, when we take the square root of it, we get 28 again. Okay. So now we're not completely done yet. If we tried that, it wouldn't be 100% finished. Because 28 does have a perfect square factor. That's the same as square root of 4 times square root of 7 over 28. And this gives us 2 times the square root of 7 over 28. And just like if this was 2 over 28 as a fraction, we could simplify that. The 2 can divide by 2 to become 1. 28 can divide by 2 to become 14. This is going to be the square root of 7 over 14. And so it's kind of weird to see, and this is as far as we can go, because 7 doesn't have any perfect square factors. But it's kind of weird seeing that 1 over the square root of 28 is equivalent to the square root of 7 over 14. Just in our heads, it might not appear like those two are equivalent, but it turns out that they are. And of course, square root of 7 over 14 is what we prefer. So remember, I moved to the right, so I wasn't under the radical anymore. I divided, and I can put the 14. And we got it right. And we can see all the same steps we just followed right there. So if you need to, when you're doing this on your own, if you need to go through and just get something wrong a few times just to kind of see what the process is, hopefully me running through all these examples is going to help you well enough. But if you need to see a few more worked out, you can do that. Okay, so let's look at 2 more. And then after that, if you still have questions, then you can stick around. And this is a good one. I'm glad we saw one like this. 1 over the square root of 2. This one doesn't look so bad, but we still don't like it in this form. And this is actually a really good one to see because next week when we're rationalizing the denominator, you're likely to see something that looks more like this. All right, no big numbers like square root of 28. We won't be dealing with that. This is just 1 over the square root of 2. So let's give it a go. So I take the square root of 2 and I want to multiply by that radical square root of 2 over itself. And 1 times square root of 2 is just square root of 2. Square root of 2 times square root of 2 is the square root of 4, which we know is just 2. So the good thing about when we multiply the denominator, we basically just get to take whatever's under the radical and make it a whole number. Now this, I cannot simplify. There's no simplification of square root of 2. There's nothing I can do with that 2 itself. So bottom line, that's my final answer. So I will write that as square root of 2, move to the right so I'm not under the radical anymore, and divide by 2. And this is actually a very common one, this 1 over square root of 2 becoming square root of 2 over 2. So as you move further in your math career, that's going to be one that you kind of just, you might get to the point where it's just secondhand. You're like, or just really quickly, oh yeah, square root of 2 over 2. So anyways, that's what we've got going on. You see the steps. Let me do one more, and I'm going to try and find one that's more complicated. Because some of these have some really big numbers here. This one's big enough. Well, let's go with that. Okay. And the process doesn't change no matter what numbers they give you. But here we've got 7 times divided by the square root of 54. So just like we've been doing, I'm going to take whatever's in the denominator, square root of 54, put that over itself. And the trick here is that when we multiply across right here, we make the irrational number rational. That's why we call it rationalizing the denominator. So we're just going to get 54 right here. Not much to that. And then 7 times square root of 54. And we're not done yet. We want to see what we can do. Now, 7 and 54 don't have any common factors. So we can't simplify just yet. But 54 does have a perfect square factor. And does anyone know what the perfect square factor of 54 is? And if anyone in the room knows. Oh, there you go. Yeah, Connor's got it over there. It's 9. So I can rewrite this as 7 times the square root of 9 times the square root of 6 over 54. And now we know the square root of 9 is just 3. So 7 times 3 times the square root of 6 over 54. And 21 times the square root of 6 over 54. Now, before we finish this problem, I want to say if there's a problem like this and you are really struggling trying to find the perfect square factors to simplify this further, then you can just put in your best guess, get it wrong potentially. When we do this next week, I want to make sure it's really clear. You are going to have square root of 3 or square root of 2. That's all you're going to be dealing with, not square root of 54. So if you know how to do square root of 3 and square root of 2, you are in great shape. If you get to a problem like this and you struggle with this step right here, this last stuff that we're doing, then, just try your best on it and, understand that it's not going to be that complicated moving forward. So 21 and 54, surely there's a common factor, and it can't divide by 2 because 21 is an odd number, but these can both divide by 3. So that's going to be 7, and 54 divided by 3 is going to be 18. All right. And you don't have to know that off the top of your head. You can just keep trying to figure out what these can divide by. So 7 square root of 6 over 18. I'm confident that there is no perfect square factor left for the radical, and I'm also confident there's no other common factors between 7 and 18. That's as simple as it gets. So 7 times the square root of 6 divided by 18. That's the simplest we can possibly make it. Well, I'm pretty confident. Let's see. Okay, good. I got the green check mark. Now, if you didn't get it right, I encourage you to look through all the steps and see where you went wrong. Maybe you didn't realize you could simplify it beyond this step right here. Maybe you got down to right here and you didn't realize that you could divide even further. So whatever the case, that's what we're working on today. If you need to see more examples, feel free to stick around. Otherwise, your work is just some delta math. It's going to be more problems like this. You have, I think, 10 of them or whatever the case. Work on this today. When you come on Monday, then we're actually going to be looking at triangles and tying all this together finally. All right. Have a great weekend. But like I said, stick around if you have any questions.
Thank you. Have a good